Hi students, it's Mr. Legg here. This screencast is on the topic area of basic shapes, 4C from your textbook. Our learning intentions for this lesson are to, one, be able to convert between different metric units of area, including hectares, although we may not get to hectares, we'll see. And two, find the area of squares, rectangles, parallelograms, triangles, and composite shapes. So there's a lot in there. What I want you to do is get your notes that Mr. Wang would have given you, open it up to this page here. Now, unfortunately, I didn't have the page numbers on these notes, but you should be able to find area of basic shapes. So just pause and grab the your notebook so you can take some notes as we go, and feel free to pause me if you ever want to catch up with the notes along the way. All right, let's get going with a bit of a lesson starter. So I want you in a moment to pause and have a go at this little lesson starter activity. So what we've got here is an enlarged drawing of a centimetre. Yeah, so it's bigger than a centimetre on the screen, but it's intended to represent a centimetre. So that distance there is 1 centimetre, as is that distance there is 1 centimetre. And you can see the little squares are millimetres. So what I want you to do is answer these questions 1, 2, 3, 4, 5 on your own. Have a go, and then when you've done that, press play, and I will step you through some thoughts as well. Press pause now. All right, girls, how did you go? Let's have a look. So the first question, how many square millimetres are there on one edge of a square centimetre? Look at this. Well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No surprises there. How many millimetres are there in total in 1 square centimetre? All right, so I've got 10 on the first row, and I've got 10 on the second row, that's 20, and 10 on the third row, that's 30, and I've got 10 rows. I think I've got 10 times 10 equals 100 square millimetres in a square centimetre, and I'm just going to write my units like that. So how could you convert between millimetres and centimetres squared and centimetres and millimetres squared? Well, it seems to me that if we've got 1 centimetre squared equals 100 millimetres squared, then all we need to do is multiply. If we were going from centimetres to millimetres, we'd be times 100. And if we were going from millimetres to centimetres, we would divide by 100. Yeah, or 10 squared. Describe how you could calculate the number of square centimetres in 1 metre and how you could calculate the number of square metres in a kilometre, and use some diagrams to explain. So let's draw it. Let's draw a square metre. So this is 1 metre times 1 metre, and 1 metre equals 100 centimetres. Equals 100 centimetres. So if I looked at that bottom row like I did before with our diagram up here and counted, how many centimetres would I have? I'd have 100 centimetres. And I'd have 100 rows. I'd have 100 rows, all of which were 1 centimetre. So if I was counting the number of square centimetres in a metre, it would be 100 times 100, which equals 10,000 centimetres squared. And I reckon I could do the same thing for square metres in a kilometre. Here's a kilometre, 1 kilometre, 1,000 metres, 1,000 metres. So I could, if I wanted to work out how many square metres in 1 square kilometre, it would be 1,000 times 1,000. 1 kilometre squared equals 1,000 times 1,000, which is 1 million meters squared. So hopefully that's a bit of a warm-up for you for converting between units of area. So let's get into it. You'll be familiar with this diagram that we used for converting between units of length. Yeah, so when we go from kilometres to metres, we multiply by 1,000. When we're going from metres to kilometres, we divide by 1,000. When we're going from metres to centimetres, we multiply by 100. When we're going from centimetres to metres, we divide by 100. Well, let's update this chart now to convert between units of area. So the only difference in this chart is that instead of kilometres to metres, it's kilometres squared to metres squared. So when we were converting between kilometres and metres, we multiplied by 1,000. When we're converting between kilometres and squared and metres squared, we multiply by 1,000 squared. When we're converting between metres and centimetres, we multiplied by 100. So when we're converting between metres squared and centimetres squared, we multiply by 100 squared. When we were converting between centimetres and millimetres, we multiplied by 10. When we're converting between centimetres squared and millimetres squared, we multiply by 10 squared. And the reverse also applies. So when, for example, we're converting between centimetres squared and metres squared, we divide by 100 squared. And this one, 1,000 squared. So you might be wondering why I've used 1,000 squared and not just written 1,000,000. So that's the first thing you might be wondering. The second thing you might be wondering is, how do I work out what 1,000 squared is quickly? Well, I'll give you the answer to both of those questions. The answer to the first question is, if you can remember this little chart for converting between length, and you can remember that area is measured in squares, then the only thing you need to update is that guy. So that's the first reason. Now, it's the first question I should say. So if you're wanting to know how many zeros in 1,000 squared, all you do is you go, how many zeros are there? 3, and you multiply it by the power, which in this case is 2. So 1,000 squared is 1 with 2 lots of 3 zeros. Yeah? 1,000,000. Let's look at 100 squared. So that is 2 zeros multiplied by the power of 2. So it's going to be 1 with 2 lots of 2 zeros, which is 10,000. So that's a good way to remember how to work out how many zeros to add. Let's get into some examples here. All right, we're going to try and convert this one here. We're going to convert 0.248 meters squared into centimetres squared. And girls, I want you to be taking notes here because it's important to lay out your working in the way that I show you. I'm going to try and keep that diagram in place because that'll be helpful for us. All right, metres squared to centimetres squared. That's the first thing we're going to write. We're going to write metres squared, arrow, centimetres squared, because that's the conversion. What do? We multiply by 100 squared, which is 100 squared. Yeah, centimetres squared. So that's the conversion factor. Therefore, the 3 dots means therefore, 0.248 metres squared equals 0.248 times 10,000. Now, there's 2 ways you can do this. One, you can get your calculator, but an easy way to do it is just to move the decimal point by the number of zeros. I have 4 zeros, so I'm going to move my decimal point 4 spots. Yeah, and the answer is going to be 2480 centimetres squared. Make sense? Let's do another one. Convert 3,100 millimetres squared into centimetres squared. All right, let's look at our diagram. Where do we get millimetres squared? It's the bottom right. It's this guy here. Okay, so we write millimetres squared to centimetres squared. We're going to divide by 10 squared, which is 100. Therefore, 3,100 millimeters squared equals 3,100 divided by 100 equals 31 centimeters squared. Yeah, hopefully that makes plenty of sense for you. So girls, what I want you to do now is have a go at these Now You Tries, but please note the changes. The Now You Tries that I had in there before were very difficult, and I'd prefer if you convert between the units that I've shown you in here. So we're going to convert 3.151 kilometres squared into metres squared, and we're going to convert 3,100 millimetres squared into centimetres squared. Oh, we kind of just did that one. How about we just do this one and we skip this one altogether? Yeah, skip this one altogether. Have a go at this one by yourselves. Press pause now, and then I'll show you my answer. All right, how did you go? Hopefully what you did first is write down kilometres squared to metres squared is times 1,000 squared, which is 1,000,000. So 3.51 kilometres squared equals, actually I might put my equals down on the next line, equals 3.51 times 1 with 2 lots of 3 zeros, which is 1,000,000, which is 351,000. And we've moved our decimal point 6 places because there are 6 zeros and the unit is metres squared. Yeah, I hope you got the same answer. All right, now what we might do with these ones is I might, when we get back to the school in term 3, I might show you this PowerPoint, but for now I might just give you the formulas, which you probably are going to be familiar with, but I'm going to give you the formulas for each of a rectangle, triangle, and parallelogram, calculating the area thereof. All right, and the area of a rectangle is length times width. The area of a triangle is a half base times height. And the area of a parallelogram is base times height. One of the things that I'll show you in this nice PowerPoint that I sometimes do is that a parallelogram is just 2 triangles stuck together. So if you know how to calculate the area of a triangle, half base times height, then you can remember how to calculate the area of a parallelogram because it's just 2 triangles. All right, so the method we use here, girls, to calculate the areas of these examples is to write the formula, substitute our values, and write our answer with units. So the area is length times width. It's a rectangle. Let's substitute those values. 7 times 3 equals 21, and the units are metres squared because we measure area in squares. All right, let's have a look at this triangle. The formula for the area of a triangle is a half base times height equals, now where's the base? This is a bit tricky because the base is actually this one here. It's tricky because it's upside down. All right, so we're going to go a half, and the base is 13, and the height is 6. So I reckon this is, you could check it on your calculator, but I reckon this is 39. And what are our units? Centimetres squared, because we measure area in squares. Area of a parallelogram equals base times height equals 3 times 1.5 equals 4.5 centimetres squared. And that is how we do it. Hopefully that makes sense. All right, girls, let's move on to composite shapes. You might remember when you were in grade 4, 5 or 6, you might have been in a class that was a composite class. Composite means something that's made up of 2 or more parts. And there's some other words in the English language that have similar kinds of meanings. Here you can see this guy is comparing two or more things. Colours that complement each other. Two or more things that go together. This dude is doing a comprehensive job looking at all those things, more than two things. These guys are communicating. You need more than two or more parts to communicate. This guy is getting some compliments. It takes two or more people to give and receive a compliment. So a composite shape is a shape that is made up of two or more shapes. So let's look at some examples. Here's a shape that's made up of a square and a parallelogram. Yeah? Parallelogram. This one is made up of a rectangle and a triangle. This one is made up of a square. That is an awful square. I'm going to draw that again. This guy's made up of a square and a circle. This one's made up of a square and 4 circles. Yeah? So what we can do when we're trying to calculate the area of a composite shape is we go step 1, break it into its parts. Step 2, calculate the area of each part. And then depending on whether we're adding or subtracting, we get the area. So here's an example. It's the example we had above where we've got a parallelogram that's been chopped out of a square. So what we're going to do is we're going to say that the area that's remaining is the area of the square, AS, minus the bit that's been chopped out, the area of the parallelogram, AP. I don't mind if you use A1 or A2. It's just that this is a great way to communicate your solution. And we know that the area of a square is length squared, or length times width when they're the same. And the area of a parallelogram is base times height. And we've been given all this information. So the length is 38 squared, and the base times the height is 15 times 12. And I might get Siri to help me here. Hey Siri, what's 38 squared minus 15 times 12? She's just disappeared into the ether. Hey Siri, what's 38 squared?
The answer is 1,444.
Hey Siri, what's 15 times 12?
It's 180.
All right, and the answer is 1264 centimetres squared. And I'll take this opportunity now to point out that in the test for measurement, you will have your calculator with you. All right, so let's do another example. Here we've got the area of a rectangle and it's had a triangle chopped out of it. So the area left is going to be the area of the rectangle minus the area of the triangle. Yeah, so the area of the rectangle is length times width, and the area of a triangle is a half base times height. Length times width is 3.1 times 5.3, which I hope you can see in the diagram there, minus a half, and the base, see the base is going to be that big. That it actually doesn't matter which one we use because this guy is what's called an equilateral triangle. Yeah? A half of 1.5 times 1.5. All right. Hey Siri, what's 3.1 times 5.3?
3.1 times 5.3 is 16.43.
Hey Siri, what is a half times 1.5 times 1.5?
1 divided by 2 times 1.5 times 1.5 is 1.125.
Hey Siri, what's 16.43 minus 1.125?
16.43 minus 1.125 is 15.305.
16.305. And how many decimal places were we asked for? I reckon I'm going to do 2 decimal places. So I'm going to see if I round up or leave it the same. Oh, this critical digit is 5 or more. So that means that we round it up to 15.31 meters squared. All right, hopefully that made sense. Now, girls, I want you to have a try at these Now You Tries by yourselves. So press pause and then press play when you're ready to see how you went. All right, we're back. I hope you went well with these ones. I'm just going to step you through my solution for these ones. I reckon this is the area of a circle. I'm going to say this is the area of a square. So the area of the shaded bit is going to be the area of the square minus the area of the circle. The area of the square is length squared. This area of the circle is, do you remember the area of a circle? Pi r squared. Pi r squared. Length is 9, so it's 9 squared minus pi times, and the radius of our circle is 3 centimeters. Pi times 3 squared equals, hey Siri, what's 9 squared minus pi times 9?
9 squared minus 3.1415 times 9 is approximately 52.7256.
All right, I want to do 2 decimal places. So I'm going to just check out my critical digit here, and it's 5 or more, so I'm going to have to round up. Equals 52.73. What are our units? Centimeters squared. How did you go? Hopefully you went well. All right. Let's have a look at this next one. We've got a circle, area of a circle, and we've got the area of a square. So here, the area of the shaded bit is actually going to be the area of my square minus 4 lots of the area of my circle. Yeah, because I've got 4 holes that have been chopped out. The area of a square is length squared minus 4 times pi r squared. Ooh, what's r here? It looks to me like they've given us 14 centimeters, but that's the diameter. So r is going to be 7 centimeters, yeah? Not 14. All right, so let's plug in those values. 50 squared minus 4 pi times 7 squared. Hey Siri, what's 50 squared minus 4 times pi times 49?
50 squared minus 4 times 3.1415 times 49 is approximately 1884.2478.
All right, let's check our decimal places, and we're going to do 2 decimal places again. Oh, look at this guy. The critical digit is 5 or more, so we're going to round up. Equals 1884.25 centimeters squared. Hope you went well with that one. All right, girls. I hope you found this useful. What I want you to do now is practice exercises from 4C. The schedule at the front on page 3 of your booklet there will tell you which exercises to tackle. And if you have any problems with them over the holidays, please send me an email and I'll be able to get back to you. All right.